All right, so this is 7.5 Reflections and Lines of Symmetry, and we have a challenge out right now. Who can make the best snowflake? We only have a limited number of pairs of scissors, so I have a few contestants here, and I'm going to make one too. Making a snowflake out of paper. I haven't really made a snowflake out of paper since I was a young lad. A lung yad. Since I was a young lad growing up in Strasbourg, Saskatchewan, out on the farm, where we had lots and lots of snowflakes. Am I embarrassing someone in this room? Am I? Okay. So I can't remember how to make a snowflake, but I am going to do my best here, and I am going to make something incredible, I think. So I have no idea what I'm doing here, and I think that by the sounds of it, it doesn't sound like some others know what they're doing either. But this is my first attempt at a snowflake here, which is going to be pretty awesome, I think. This is, I'm just basically cutting things up. All right, so let's see about this one here. All right, here's my snowflake.
Yeah.
It kind of looks like a mutant spider that's grown many two legs. Many two legs. I can't this morning. Too many legs. All right, so time is almost up. Let's see the. You got 10 seconds left, bro. Yeah, I'm not sure. You need a pen? What do you need a pen for? All right. This is my snowflake. That does not look like a snowflake. 8, 7, 6, 5, 4, 3, 2, and 1. Okay, everyone stop. So we're going to show the snowflakes one more time here, and you're going to cheer for the best looking snowflake in your opinion, okay? So we're going to do this by cheer. Okay, ready? This is the Mr. Maxwell snowflake.
Yeah.
Okay, all right. Bonus marks. Okay. Whose snowflake was this next one?
Yeah.
All right, okay, Brandon, okay. Okay, all right. That's in the lead so far. Nice. Better than mine.
It's not saying much.
Snowflake number 3. Okay.
It wasn't even that loud.
Okay. And snowflake number 4.
Yeah! Come on.
Okay, all right. So I think snowflake number 3 did take it. So congratulations, Anna. Good job. This is your snowflake. Now, so what is the best way to make snowflakes? Actually, I'm going to change this here. Okay. So help me out here, snowflake professionals. Like Anna, you're pretty good here. That's pretty nice. So what did you do? You folded it up.
I like put it, when you make fortune tellers, you like that, and you're like.
Okay. So you don't really know what you did? Oh, really? So you just like folded it randomly, like just fold it kind of randomly, and then just started like whacking away with the scissors? What? Okay, isn't there like a way where you like fold it, and then don't you like fold it again or something like that?
That's what I think that's what like a cow did, but she made it into a square first.
Okay, here's the middle. If I fold that, what if I like keep track of the middle somehow? Is that gonna work? I don't know if this is gonna work. Here's the middle still. There's the middle. I don't know. I don't even know what I'm doing. That's the middle. Should I try and fold it again? No? Okay, I will. All right. Thanks for the input. And I'm gonna keep track of the middle there because I want to keep the middle, but I'm gonna do a little bit of the contest winner's advice of just like folding randomly. Okay, so here's the middle. No idea if this is gonna work. I want to keep the middle, but I'm gonna like start to chop everything else. I just want to see if this is gonna work. So here we go. I feel like This is a disaster waiting to happen. I need to remember where the middle is. Okay, here's the middle.
We love it.
Oh, I almost took an eye out there. Okay. All right.
You gotta cut your finger.
I might cut myself. Yeah, that's true. Middle was, I think, here still. Okay, let's see. So, what do you mean, uh-oh? You don't think this is going to work?
Yes, it's not gonna work.
Yes, it's not going to work.
Yes.
Thanks for being so optimistic.
No, it's not gonna work. Not yes, it's not.
Okay. No, it's not going to work. Yes, it's not going to work. Okay. All right, so let's, there, I just made little cuts. You see, little cuts all around?
Wow.
So pretty? Doesn't it look like nice just like that? I don't know. Okay, let's unfold it and see what happens.
It might have worked.
It might have worked. Oh, now it might have worked. You think? I don't know. Let's see. Oh, that's still kind of like, it's something. That's not too bad, actually. All right, that's not too bad. Now, I want you to look carefully at these. This is kind of bust here, so I'm gonna, I don't know what happened there, but if you look carefully at all of these snowflakes, except perhaps maybe entry number 4. I don't think entry number 4 is going to qualify for this lesson. Sorry. But if you look carefully at all of these, you should notice something, that they are what? What's the word that starts with S? They are symmetrical. Yes. Yes. This one, I think this is fairly symmetrical. I wonder if this could be symmetrical in different ways. Like I'm kind of seeing an up and down line, right up and down through the middle. That looks pretty symmetrical. Because if you fold this snowflake over that line of symmetry in the middle, do all of them, yeah, look, they all line up. All of the holes line up. That's cool. What about this way? If we turn it this way, do these ones work? Let's just see. Ah, not quite. Now, look carefully. I don't know if you can see this, but the holes don't line up if you fold it this way, you see? So, technically, this line right here is not a line of symmetry, but this line, I'll switch it around, this line would be called a line of symmetry, all right? Now, my wonderful snowflake, the mutant spider snowflake, there's a vertical line of symmetry here. Do you see that? Because if you fold this over on itself, it exactly maps onto itself. You see that? So if we were to fold these, if they have a line of symmetry, now let me see about this one here. This one's pretty. I'm thinking if I hold it up like this, if I fold it this way, let's see, does this work? Oh, look at that. All the holes line up. So that's a line of symmetry where I folded that, okay? All right, so there's your real life example. And we're going to talk about lines of symmetry here now that I have pieces of paper strewn about my workspace. All right. Oh, that was nice. What do I have on here? Okay. All right, so let's get back to the lesson. Open up your notes there if you don't have them open. Hopefully you have them open. 7.5 is reflections and lines of symmetry. The Taj Mahal is a famous example of symmetry in architecture. So let's zoom in a little bit. This is the Taj Mahal here. And I hope you can see that there would be a perfect line of symmetry if we were to draw this line. Let me just get an actual line here drawn. So from here all the way down through the middle, okay, that would be a line of symmetry there. And everything on the right, you see, maps over to something identical on the left. You see that? Now, this is a real life structure, and it's pretty symmetrical there. Even the trees, okay, all that sort of stuff. The windows and openings, all that sort of stuff. So that's a line of symmetry. Now, I have some other just stock images from the internet here. Obviously, this is a literal mirror that this lady is standing in front of. And so this is a bit, this is not a geometric, line of symmetry, but you can see the mirror is right here. And so everything on this side of the mirror matches exactly with this side. Now, the perspective is not straight dead on because we'd have to take the picture right in the surface of the mirror, which wouldn't work. So it's shifted off to the side a little bit. So that's why it looks maybe just a little bit different. Like she's actually looking this way, and this she's looking right at us here. So that's the slight difference, but you get the picture, right? A mirror image. Over here on the right, this is a picture of a flamingo, and there's a line of symmetry right down the middle here. right? Somewhere right around, let's see if I can move that over to the proper spot. Come on now. It's popping back and forth. Oh, getting close. And let's see if I can move that around. Sometimes this doesn't really behave. Okay, so somewhere around there, right? You can see that. Okay, so in geometric figures, we also have lines of symmetry. So let's talk a little bit more about it. A figure is divided into two congruent parts. Who remembers what the meaning of congruent is? Yeah, same, like exactly the same. So same shape and same size, right? If we're talking about polygons, congruent? Identical, yes. So a figure is divided into two congruent, so the same parts, using a, what do you think you want to fill in there? All right. So line of symmetry is correct, and line of symmetry, get your notes. In brackets, you might want to put mirror image here. Mirror image, okay? Using a line of symmetry, and think of, like in these diagrams, a mirror image. One half of the figure is reflected exactly onto the other half. So these little black lines that I drew up at the picture of the Taj Mahal here. So, oops, I'll get that line of symmetry back. So each figure, okay, so this little tower right here, has an exact representation on the other side, the same place, the same height, the same position as the other. So each part is reflected onto the other part. Now, if you put your hands up in front of your face like this, with your pinkies touching, if you disregard any jewelry you might have on there, this is a rough mirror image right here. The line vertically right through where your pinkies touch there would be a line of symmetry, because you could fold your hands right onto each other, okay? Disregarding the wrinkles, stains, scars, whatever. But that's that's a pretty good idea. Now, if you put your thumb to your pinky, like that, you might think, hey, there's a line of symmetry as well right here, but not really. If you fold your hands over like this, they do not match up exactly, right? So this one works, boom, right? But this one does not work, okay? So left and right-handed. Now, your left hand and your right hand would look very similar. There would be corresponding parts, but they are not congruent, right? They are not congruent. You put your left hand on top of your right hand, your thumbs don't match up unless you flip around. But they are not congruent if you just look at them like this. They are similar, I guess you could say, but they are mirror images of each other, okay? So that's a very real example that you have right attached to your body right there. Now, a line of symmetry, down the middle of your face, okay, is pretty close, barring all the scars and stitch marks that I have from hockey and stuff like that. But if you draw a line right through the middle of your nose, even the glasses on my face, right? 2 ears, 2 eyes, half of a nose, half of a mouth, chin, soul patch even, look at that, it's symmetrical, look at that, right? I should come tomorrow with like half my face shaved. What do you think? And then, am I symmetrical today? No. Yeah. Maybe you grade 9 boys can do that for me. Would you guys just shave only half of your beards off? Forget it. Right. Forget it. Just shave right down the middle. Now, don't tell your parents I told you to do this. I'm not telling you to do this. But shave right down the middle like this and just shave one half. Just say, Mr. Maxwell needs help teaching about symmetry. Will you help him out? Oh, aren't you nice? Sisterly love there. You'll probably do it. You'll probably do it for him. Would you shave his head? Oh, okay. All right. Not my idea. Your idea. Not mine. Okay. All right. We'll see tomorrow. All right. A figure may have more than one line of symmetry. So we almost had it. Or did we have 2 lines? No, we almost had it with this one, right? We almost had 2 lines of symmetry. Or do we have this? Oh, you know what? This diagonal lines up. And didn't one of these line up too? Yeah, look at that. Anna the King. 2 lines of symmetry. Nice. You probably didn't even know you did that. Line of symmetry up down the middle there. Well, besides the hole punched holes, I guess. But line of symmetry there because it folds onto itself with all the holes matching up. And a line of symmetry right here this way with all the holes matching up. Beauty. Okay. So we could have 2 lines of symmetry. Or more, even. The line of symmetry is also called the line of reflection. So let me get back to my notes here. Can be vertical, horizontal, or, are you ready for this one? This is a new term that you're going to need in later math. It doesn't pop up very often. I'll give you that. But you need to know what this word means. Oblique. Oblique. Okay? Big, fancy word that you probably won't use much outside of math. I think on your body here, these oblique muscles would be these muscles on the side of your torso, I think. You know this, like the 6-pack, the muscle bound, the ripped, like, I would show you mine, but it's inappropriate. I have a picture of one underneath here. No, yeah, mine. I don't have one. I have a 1-pack. I've been working on that for years now. Anyways, but you know what I'm talking about, right? The oblique muscles would be the muscles that are kind of on the side. They're slanted, okay, like that. You have your 6-pack of abs, and then you have those oblique muscles. So they're slanted. So oblique means slanted. And in math, right? In math, where we use this word this is a vertical line. Ah, okay. Line of symmetry can be vertical. A line of symmetry can be horizontal. Well, here's a horizontal line, right? It's flat, like the horizon. If you look in the distance, the horizon is fairly flat. And oblique would be a line of symmetry that is slanted or, like this. So not horizontal or vertical, like a diagonal. Yeah, like kind of diagonally drawn, for sure. A diagonal would be more technically, I think, a line between one corner and the opposite corner of a figure, a diagonal. But yes, a diagonal would be an example of an oblique line. So here's an oblique line right here. Now, this is not a line of symmetry in B, actually. That's not a line of symmetry. We're going to get there in a second. But oblique lines can be lines of symmetry. All right. Any questions there so far about any of these terms or anything we've talked about? Questions? You guys are good? All right. So example 1, is the dashed line in each figure a line of symmetry? Let's take a look at A. Now, is A a line of symmetry? Yes. If you were able, could you fold that triangle one side over the line of symmetry, and would it exactly match with all of the points and sides and angles on the other side? Yeah. If you envision this as a mirror, all corresponding points and parts would be exactly the same distance away from the mirror and in the exact sort of opposite position, right? So if you've got a part that's slanted this way, the part on the other side of the mirror would have to slant the opposite way, not the same way, right? Okay, all right. What about B? I already said B was not, but I want you to think about this. If this was a piece of paper, and I happen to have a piece of paper, forget about this, but a piece of paper like this, if I were to take the corners of this piece of paper and fold it along the diagonal, okay, or this oblique, proposed oblique line of symmetry from corner, here's my corner to corner. It's actually not as easy as you think it should be. This is not going to be very good at all. But anyways, it's kind of like folding a Kleenex, right? Shoot, sorry, I cut this off. I cut the staples out of this to recycle this paper. Aren't I nice? Okay. So there we go. So you see how the corner or the edge, the corner piece and the corner piece do not exactly line up, right? So in a rectangle, you wouldn't have a diagonal line of symmetry. You would have a horizontal line of symmetry. That folds exactly onto itself. And you'd have a vertical line of symmetry. Folds exactly onto itself. But not a diagonal. If you had a square, would that change? Yes. Would it change if you had a square, you think? Yes. Okay, let's see if I can draw a square here. Let's see if I can put a square here. Let's see. Now, to my view, that looks pretty square-like. That looks pretty good on the screen, too. Now, if I were to draw a vertical line, that would be a good line of symmetry. Horizontal line would be a good line of symmetry. And if it was a square, an oblique line would be, let's see if that would be a good line of symmetry. So let me see. I'm going to actually make a square here. Yeah. So here's a square. I can fold it this way. Perfect line of symmetry, yes. I can fold it down this way. Perfect line of symmetry, yes. And the diagonal, all the corners should line up. The corner should line up here. And when I fold it here, it should go right through the other two corners, and it does. Okay? So that one works as well. So squares work. They have lots. 1, 2, 3, and 4 lines of symmetry. Okay, moving on. C. Is that a line of symmetry? No. Nope. Nope. If that top folded down, it would look more like this, right? So that would not line up, obviously. And what about D? What do you think? Yes, D, for sure. D. This would fold right over onto this part, this corner onto this corner, that corner to this corner. So when you look at the line of symmetry, if you look at corresponding parts on either side, they would be the exact same distance away from each other in a perfect line that makes a 90 degree. So it's a perpendicular line. So watch this. This point over here should be the exact same distance away from the line of symmetry as its corresponding point over here. That is true. And does this make a 90 degree? Yes, it does. So perfect. If we look at this point right here, the exact same distance to this point. And is that a 90 degree angle? Yes. This side to this side, same distance, 90 degree on this sort of line that connects the corresponding parts and so on. So this right here, look at this. This corner to this corner. Ooh, yes, that's the exact same distance, but is this a 90 degree? No, it's not. So we do not have a line of symmetry there. Does that make sense? Sorry, that line is really bad, but this line, if you drew a straight line from corner to corner, corresponding part to corresponding part, they could be the same distance, but if they don't make a 90 degree there, you're in trouble. Okay. All right. On the next page of your notes, let's examine the hexagon. The hexagon, one of the champions of symmetry, hexagon. Is each line a line of symmetry for the hexagon? So let's take a look at this line right here. Do you think that this line in the first one is a line of symmetry for the hexagon? Okay, I would agree that each point here is exact same distance away from the line of symmetry and forms a 90 degree angle with the line that connects them. Okay. What about this one? This next one over here. Would that be? Okay. Now, notice that if we have a line of symmetry, where'd my square go? If we have a line of symmetry that is vertical here, and if I were to tilt this actual physical shape, the line of symmetry would now look oblique, wouldn't it? So check this hexagon out. It could be argued that if this is the top of the hexagon in this picture, it could be argued that this picture is just tilted on the side. You see that? It's a regular, and it could be tilted another way too. It could be tilted all the way around to here actually, right? Totally. But if this is a regular hexagon, remember what regular means? All angles, corresponding angles are equal, and corresponding sides are equal. I should say all interior angles are equal to each other, and all the side lengths are equal. That's a regular polygon. So this is a regular hexagon. It literally just tilted like this. It's the same one. This one too. I don't like how this line is drawn. And maybe this is on purpose. I think this might be on purpose actually. But this line right here, it doesn't go through the middle of this side. So because that does not go through the exact middle of this side, and maybe not through the middle of this side either, this is no. So we got yes, yes, but you see how that's a little off a little bit? So this part right here is not the exact same distance away from its part on the other side of what would be the mirror line. It's not the exact same distance. So that's no good. And this would technically not be a 90 degree. They would not be 90 degree angles anywhere here. All right, what about this one through the corner and the corner? Through a vertex and a vertex here, let's see. Yeah, if you tilt your head sideways there, this part right here is the exact same distance away from this part, and it makes a 90 degree angle, so we're good. This one, next one?
Yes.
Yes. It's the same as this one, just kind of switched around. And what about this one?
Yes.
Yeah, for sure. Yeah, very good. Okay. Could there be any more lines of symmetry drawn for a hexagon than you see here? Yes? Oh, okay, okay. So, yes, no, okay. If this one was drawn a little bit differently, you say that this would be another one, right? If this was drawn right through here, okay, I can't make a straight line on this thing, but. So if that was in the middle, that would be one. Okay, yeah, good. What about this one? Okay, what about this one? Is that a line of symmetry? I'm hitting this. I've got these points are exactly the distance away from what would be the middle. I don't know. Is this a line? No, that's not the way we do it. We have to look at a point on this side of the line of symmetry and see if there's a matching point over here. There's not. This one does not have a matching point over here. That is not a line of symmetry. And common sense and objective reality tells you that that line, if you were to actually have that figure cut out, if you were to fold it on that line, it would not match itself to the other side. Okay, good. If this line was moved over, to the middle, then yes. If that was a straight line, that would be good, same as the first one, right? That one's good. This is not, nor is this. Or this isn't. Whoa. What is that? That is, I'm trying to, what am I trying to do? I'm trying to grab, I don't know if I can now. No, I can't. I'm trying to twist it. Okay, fine. You know what I can do? I can draw this line. There we go. I'll draw this line. Okay. So is that line a line of symmetry right there? The middle there, right through a vertex? Nope. Again, you can't fold it. Okay, I think you guys get it. You guys. Yeah. Awesome. Okay. So in this next part, I want you to draw all lines of symmetry for these regular polygons. Take a minute. There may be one, there may be more than one. As we know in the hexagon, right, there's a lot more than one. So for all of these, draw as many as you can draw, okay? And then we'll move on to this chart. So take a few minutes and just do that. All right, here's the big reveal. Compare your diagrams to these ones on the board here now. Let's see, for the triangle, these are regular polygons. So the triangle should have three, count them three, 1, 2, 3 lines of symmetry. There are no other lines of symmetry for the triangle. The square should have 1, 2, 3, and 4. A total of 4 lines of symmetry. The pentagon, 5-sided, should have, let's see, 1, 2, 3, 4, 5 lines of symmetry.
And 4 branches.
And what?
4 branches.
4 branches?
Pentagon, military.
Oh, yeah, okay. Yeah, the pentagon, I see. Okay, and the hexagon, how many lines of symmetry? Let's count them. 1, 2, 3, 4, 5, and 6. Okay, so back to the notes here. Let's fill out this chart. According to your diagrams, how many lines of symmetry exist for a triangle with number of sides 3? There are 3. How many lines of symmetry were there for the square? 4. How many lines of symmetry for the pentagon? And for the hexagon? So what is your guess, based on this information, if we have a regular polygon with n sides, could be any number of sides, but it's a regular polygon, how many lines of symmetry do you think there will be? N. Yes. So if we were to make a general statement describing the relationship between the number of sides and the number of lines of symmetry that can be drawn in and this should be, please add this, in a regular polygon, what's the general statement you can make? The number, I like it. The number of lines of symmetry equal the number of sides in a regular polygon. Wonderful. You guys got it. Let me just squeeze that onto the same page as my chart there. Excellent. the number of lines of symmetry equal the number of sides in a regular polygon. So what about a rectangle? A rectangle has 4 sides, but it's not technically a regular polygon. That's why we added this to make it applicable to everything. So if it's a regular polygon with 4 sides, it has to be a square. Yeah. Good question. Any other questions or about this or thoughts about it? All right. All right, so the figure represents half of the shape. Create the final shape by constructing the missing half. Okay, the line of symmetry is BD. So the line BD is right here. It goes from B to D. Try and highlight that as best I can. That's the line of symmetry, so our job is to complete the shape. Okay, so what you can do is you can identify significant points if you want. I like doing that method. This point right here is significant, so let's go 90 degrees to the line of symmetry and the exact same distance on the other side, somewhere about there. You can do your best. You can use a ruler, but you can also just do your best to guess. This point as well would have a partner right over here. So if you connect the points like this, there we go. That side matches this other side, and then like that. And then this C point right here would have another point directly on the other side, and so this is what the rest of your diagram would kind of look like. If you have a ruler, please use your ruler, because I really can't on my little tablet here, and it looks terrible. Okay, but that's what that looks like. All right, that's pretty easy, right? Okay, what about this next one? The line of symmetry is CD. So here's the line of symmetry now, this CD. So we have to go, and you can extend that a little bit if you want, and we have to now go flip this down. Okay, so corresponding sides have to be exactly kind of 90 degrees from the line of symmetry. This B would have to be the exact same distance below the line, so that would be B prime, let's say. And so we would draw a line here. Oh, okay, make that straight. A would be exactly the same distance from this line of symmetry over here. So we have this corresponding line, so that'd be B prime, this is A prime. And then we would have another point right here that matches with this one. And then we would connect right here. So it looks something like this. And C prime would actually be the exact same point because these points lie right on the line of symmetry. You see? All right, line of symmetry is AB here. AB. So here's the line of symmetry. And what we want to do is we want to draw the shape. Now I would kind of turn my head sideways a little bit and say, okay, this is a good workout. This point right here has to have a partner point right on the other side of this line, same distance away. A and B are going to be the exact same. Now C and D are going to be a little tougher if you have a ruler. That would be excellent. This was going to be really perfect for you. But D is going to be about over here, I guess. Well, about over, where did I say? Over here. And C is going to be over, about here. And then I start connecting the lines. There, there, and there. Okay, so that's D prime, this is C prime. And A and B prime are the exact same because they're on the lines of symmetry. It looks like a, what is that, it's like a stealth bomber or something? I don't know. I was big into planes when I was your age. I was going to be a fighter pilot when I was your age, you know that? I wanted to fly an F-15 or an F-18. Oh. My dad was in the military when I was born, so I thought I'm going to be a fighter pilot. But being a math teacher is pretty much the same. Right? Yeah. It's just as exhilarating. Okay, that's moving on. Okay. All right, what's this one all about? Any questions about those lines of symmetry? No? Good. All right, moving on. Reflecting on the Cartesian plane. So just so you know, the Cartesian plane is like the X, Y axes and all the points that are kind of contained. That's called the Cartesian plane, okay? When you see that. So, if we reflect across the y-axis here, so ABCD is the polygon that we have, that's our original. Reflecting across the y-axis would give us which shape? which shape, this one, 1 or 2, which one gives us the shape when it's reflected across the y-axis?
2.
Number 2, right, because this is the y-axis up here. So if this is reflected, this actually looks a little bit smaller. I think it's supposed to be the same, but just the way this is printed, I think, just didn't quite print very well. But let's see. So 2 units from the y-axis and 2 units. So this is d prime right here. So d prime, let's write that d prime coordinate. So remember how to do this. You always start at the origin. You count the x direction first. 1, 2. So it's going to be positive 2. And then 1, 2, 3 up. That's positive 3. Awesome. Okay. A prime is going to be over here. Is that right? Oh, careful, careful. This is not A prime. No. You see, this is on the left, this is on the left, but that's not how mirror works, right? So A prime is actually where? Is it down here?
No.
Up here?
Yeah.
Perfect. All right. Caught some of you sleeping. That's okay. So A prime is this point right here. Well, let's count it. Let's count it. We're going from the origin. We're going to go 1, 2, 3, 4, 5, 6, 7, 8. Nope, 7 over, my bad, 7 over. And how many up do you think? 1, 2, 3, 4, 5, 6. Are you noticing a bit of a pattern with these two so far? I think so. Okay, here's B prime. So what's B prime? The point is -8. Look at this, -8, positive 3. So without counting, what's B prime going to be? Positive 8 and positive 3. Yes. So when we reflect about the y-axis, do you notice that all the y values stay the same? And what happens to the x values? They change to what? To their opposite value. Yes. If they have a negative, they become positive. And if we were to flip this way, the positive would become negative. So yeah, so this is going to be a positive 3, 6 here. Wonderful. All right, really quickly as we kind of conclude
Just a
here.
reminder that today is your last day to get your banquet.
Ooh, banquet tickets.
Thursday
Better get
Christmas
those.
banquet.
Christmas
If you
banquet.
did not bring your money today and you still plan to go, could you please just come to the high school
All right,
office?
A prime is
Again,
down
today's
here. Is
your
that
last day
right?
to Get your banquet tickets.
Is that right? A prime?
If you did not bring your money today and you want to go, please
No.
stop by the high school
I heard some yeses. That's a no. A prime is down here. Remember, reflected exactly opposite of where A is. So what's going to change? Is the y value going to stay the same or change for A? What do you think? The y value is going to change. What about the x value? Is it going to stay the same for both? Yeah, the x value now is going to stay the same. And the y value changes to the opposite. So -7 and -6. All right, that's the bell to finish class. I think I've given you a good start on this. We will work on our assignment for tomorrow's class. That's the end of the lesson. Please, before you leave, finish this piece right here, okay? Just a few things to do. Finish your piece right here. I'll give you some time tomorrow to work on your 7.5 assignment. Thank you.